in this session today, we are going to talk about how can we run KeyCloak, which is an open source identity provider solution, open source SSO solution on the Google Cloud and cloud offering on the Google Cloud Run offering. Okay, so let's talk about on the whiteboard. Let me just share the whiteboard. Okay, so first of all, if I talk about before talking about KeyClocks as a service, normally when we talk about an SSO or a single sign-on solution or an OIDC or OAuth, okay. So basically, KeyCloak is an open source solution for these standards. Okay? It implements the OAuth 2.0 and also integrated with the OIDC provider. So what normally OAuth workflow is like the client, which is basically an application. The application has a application, and we have the backend, right? We have the backend system, and the normal flow is that this backend system has a DB which contains the credential, and when the user has the login form, the input username and password lands on the backend and backend verified with the help of database. This is a very basic flow. Second is to decouple this DB in a different IDP like identity provider solution, where we have this client, again the client, we have the backend, and we have a separate identity provider, okay, separate authorization server solution, auth server. So here this acts as an auth server itself, but here this acts as an auth server and this acts as a resource server. Okay. Now, when the client app needs to access some data from the backend system, it has to log in via auth server, and this is how the interaction happens. It presents the request, it returns back the authorization code or the token directly. Then in every other request, the token will pass on to the backend, and backend allow that data to be returned back to the client application. It could be a browser-based application or it could be a mobile app. Okay. Now this authorization server solution is being provided by KeyCloak. Now we have the capability within the KeyCloak to act as an authorization server. Basically, the KeyCloak has a code which can be run in the form of Dockerized image within any of the cloud solution like Cloud Run or App Engine or any that supports the Docker image or containerization. Okay, so this KeyCloak act as a authorization server which has the capability to integrate with multiple identity databases, like it could be LDAP services, it could be organization Active Directory. Okay, so there are multiple integrations is also supported by the KeyCloak. So a couple of years back, like KeyCloak was actually running on the JBoss server, Wildfly or JBoss. Okay. So recently, KeyCloak has introduced a capability which we can run it on the OpenShift. We can run it on any of the managed Kubernetes solution, okay, like EKS, AKS, or GKE. Okay, or we can also run it on the serverless solution. Like if I talk about, we can run it on the Cloud Run or AWS App Runner, okay, or AKS App Engine. Okay, so KeyCloak has been evolved a lot, and in the recent version in 22.0, it drops all the older legacy support and comes everything with cloud native solutioning has been developed by KeyCloak. So on top of it, I'm going to talk about the architecture, how we have implemented one of an enterprise solution for a startup or I don't want to disclose that thing, but yes, that startup is actually looking for an immediate like solution which depends upon the open source authorization solution, and also we can make use of it with very bare, like we should have a very cost optimum solution. We may not be requiring, like they may not be going with EKS or AKS to start with. So I also think that for a startup organization, we don't require EKS or AKS on day one. So we may require some solution which works as immediate as possible and gives us the good customer experience, and then basically good time to market and gives immediate experience, and we can get the feedback out of it. And this is how the startup should be built upon. So this kind of requirement is being fulfilled. Let me just create a new document and then talk about it. If I can just create a new page. Okay. Yeah, so let me just talk about the solutioning. Okay. In general, I'm going to take it as the general startup requirement is to have like SSO or auth 0 support. Okay, this is the requirement. Second is there are some data, static data. We can take an example of static data like country data, city data. All this data is sitting in the resource server. Okay. Now the requirement is we we have an app which could be an iOS or an Android app. Okay. It should support specific region, like in case of GCP, we have saying it as Asia South 1, okay, as a Mumbai region, okay, it should be regional, okay, and it should support caching a CDN like kind of solution where it should have a edge network, or the experience to the end user sitting within India should be good. So should have some support to have CDN backed storage services, CDN backed storage services, which will hold user upload data like images or some country specific like India country specific maps, okay, can be stored over here. Map images, I would say. Okay, basically it is powered by drone images taken by the drone. So those images are actually should be stored in the backend system and should be served by a CDN. Okay, that was the requirement. So to fulfill that requirement, we actually chose GCP and KeyCloak as a service. We go with the Cloud Run to keep the cost as minimum, and this is basically is a serverless kind of a solution where it gives the capability similar to what normally GK gives to us. But in the GK, we managed most of the things. But in case of Cloud Run, most of the things are taken away from us, and we are mostly configuring things, whether it is scalability or backup, etc. All of these are taken care by the configuration within the GC. Okay. So now it runs on top of Knative, like basically it runs on top of Knative itself. So yeah, so we chose this, and now for the database we chose MongoDB, which runs on the Atlas cluster, okay, which is again managed, which is which we have chosen the GCP itself as a solutioning behind the Atlas cluster, okay, and we also make use of the Cloud SQL, which is basically to back the KeyCloak. Basically, KeyCloak also needs some database, right, to keep something like user data, etc. We can keep with the KeyCloak itself, or we can delegate to the organization system by connecting with it. So the KeyCloak itself is backed by some database. So here we have chosen Cloud SQL. Okay. Although it supports 5 to 6 databases. Okay. So what our architecture looks like. So the architecture we gone through, like we have a like initially we set up the KeyCloak. So what we did, like so KeyCloak has two mode, development mode and a production mode. Like we can create an image in development mode and production mode. Okay. So that when we create an image in development mode, it is not much optimized. Like it is not very compressed image. There are some debugging enabled, etc. The image is not optimized for production. Like there are certain things which are not specific for production, scaling, etc. In the image, like Docker image that is supplied, they also have a different image for production. Okay. So and also in the production there are a lot of different requirements. Like in the production, what they say that if the KeyCloak image is deployed in the server, that should always be SSL request. It should always be SSL enabled. Like you cannot entertain HTTP request. It should always be entertaining HTTPS. Okay, it should have a certificate installed, SSL certificate installed. So all these are requirement of production specific mode. But in development, there is no restriction. We can have an edge system, like we have a proxy kind of load balancer or an Nginx sitting in front of it, and then we can have a KeyCloak after it. So here in this structure, it is possible in development mode. In production mode, it's not. There is restriction. So here they are saying that okay, that proxy can receive the request in HTTPS, and I can receive the request in HTTP. Okay, so here it says that you can configure it with the edge as an option. Then I will work like this. I will simply receive the request in HTTP and then can return the response in HTTP. This edge or proxy machine can take care of the HTTPS. Okay. So here there are some cache like let me just create a diagram. So what we did, we have initially we have HTTPS load balancer. So this is like GCP architecture basically. Okay. So the request lands on the HTTPS load balancer, okay, which is this is user. Okay, this is user. So user and sending the request. Okay, so it lands on the HTTPS load balancer. Now this HTTPS load balancer is we have multiple backends. Okay, so we have backends. There are different CDN enable backend. Okay. CDN enable backend, and behind the scene we have storage accounts, different storage accounts. storage account 1. Let me say cloud storage. I've been into multiple clouds, so I just chose the term from the Azure. So this is cloud storage basically. Cloud storage. Now, why this 3 cloud storage? What are the purpose of this cloud storage? Let me just keep over it. So one of the cloud storage is actually holding up the static data. Okay, static data means like data associated with like if we have a country data, city data, or some other data. So all those images belonging to that data, we are keeping it in a separate cloud storage bucket. We have other cloud storage bucket which holds the static website. Basically, you can. This is a React website. To host the React website, we are putting it in this cloud storage. Okay, so this is for static website hosting, okay. And this is for dynamic data. Basically, the user normally there is a provision in the app where the user can upload images or data or video, etc. So for that, we have actually make use of this storage bucket and exposed it with the CDN. Now for the upload, we are making use of the as we are making use of signed URL approach, okay, where the URL is signed. Let me just finish the diagram first. So this is the backend. This backend is nothing but backend service is nothing but Cloud Run service. Okay. Backend is nothing but Cloud Run service, which is running. In our case, it runs the Java application, okay, which receives the request. And this is also a resource server. And then we also have one more Cloud Run service. And this Cloud Run service is hosting the KeyCloak. KeyCloak Docker image, basically. It runs the KeyCloak Docker image. Okay. And this is backed by Cloud SQL. To host the user data, basically. User data means user credential, you can say, not user profile data, like ID, username, password, email ID, all of these things is present in this Cloud SQL. And then this two machine can talk to each other. One way, as of now, there is no need of KeyCloak is sending request back to this resource server. This is a application is talking to Cloud Run. But yes, in a webhook request, it could be possible. But yes, as of now, we don't have that case. So the backend Cloud Run to Cloud Run communication is going on. Okay. Now this resource server is backed by database, as I talked earlier, and this database is nothing but Atlas MongoDB. Okay. This talks to MongoDB. Okay. Now we are making use of to save some cost. Okay. So we don't want to go directly into the premium tier and choose directly the MongoDB Premium Atlas. So what we did, like this is a free tier, and free tier, the disadvantage of free tier is that it does not give us capability of connecting it to via VPN. Okay, sorry, via VPC, I would say, via network internally. So it allows us to connect to it via public IP, and it gives us the capability to whitelist the public IP. Okay, then only it allows the communication to the MongoDB. Okay, so this is a challenge. To save cost, we chosen this, but again we caught up in the challenge. Okay. So to solve this challenge, what we did, we make use of the VPC access connector service by the Google Cloud. Recently, Google has launched Direct Connect. We can also use that, but yeah, it was like 10 days before. So the VPC access connector, what it means, like if I just go and draw a small Cloud Run diagram. So what it means that normally Cloud Run is in the VPC, is in the virtual network created by the Google Cloud. It is not associated with our network. So Cloud Run to talk to the VPC virtual network. So that access connector is necessary, VPC access connector. Okay. So we need to create a subnetwork, like we need to create a subnet in the same region. Like in this case, we are using Asia South 1 region. Okay. So the Asia South 1 region, we first created a subnet, like custom subnet, and then we associate this with the VPC access connector. And by configuring and enabling the VPC access connector here itself in the Cloud Run. Okay. So whenever the request egress, you say egress. Okay. Egress is occurring via VPC access connector. Now, why we have done this kind of a setup? Because Atlas has a requirement that I can only whitelist a public IP. Now, if we are not using this, okay, and directly connecting Cloud Run to the Mongo, so we are not able to achieve that because there is no egress static IP associated with the Cloud Run, and normally the IPs keep on like there is a change in the IP by which the request lands on the MongoDB. So to have a static IP associated with the Cloud Run egress traffic, so we have created this setup. By this setup, we also have registered the static IP here. Like we have to reserve a static IP. So whenever a egress request lands out of the Cloud Run on the VPC access connector to the to virtual network and then to the Atlas, it gives it actually lands on the Mongo Atlas with a static IP, and we whitelisted that static IP in the Atlas. And this is how we are able to connect both Cloud Run service, like resource service, to the Atlas by using this approach. Okay. Now, Cloud Run to Cloud Run, by default, when we provision Cloud Run, it gives us the HTTPS domain name by default, the Google itself. Okay. So these two servers talk to each other with that particular domain name. And this Cloud Run KeyCloak is talking to Cloud SQL. Now, this Cloud Run Cloud SQL can also be, there are two ways to connect to it. It could be public. Public by default, there is a, in the documentation, it gives an option of going to public approach, like using the public IP or of the Cloud SQL, okay, using the Unix socket approach, or we can also do it with the private network to this Cloud SQL. Okay, for that you need to enable this Cloud SQL, run this Cloud SQL in the private mode. So either of these we can use. So currently we're going with the public one, considering the shortage of time. But yes, the private, we can also go with the private one. I ideally should go with the private, but sometimes Google in documentation recommend this approach. But so this can be done with the private as well. So KeyCloak, the challenge of hosting a KeyCloak within this Cloud Run is critical to understand. So what was the challenge in the KeyCloak? If I take you to the KeyCloak, I just don't want to go there, but so there are two modes I told earlier: development mode and production mode. So in the production mode, when we are running this KeyCloak in the production mode, so it always gives us like we always have to serve this with the HTTPS. Okay. Now, what challenge is, Cloud Run is by default act as a SSL terminator. Okay. It terminates the SSL request on the Cloud Run by default. This is the behavior of Cloud Run. Okay. In the Cloud Run documentation, it says that it acts as a proxy. Like that receives the request in HTTPS way. Okay, and then terminates the SSL itself on top of Cloud Run itself, and then pass on the HTTP request to the image that we have posted on the Cloud Run. Okay. Now, if we are running it in the production mode, then that's why it was not able to work, because it is designed to work for HTTPS. If I run KeyCloak in the production mode, then it is designed to run in the HTTPS mode, because of which it was not working. And currently, what we have done, like we have optimized a little bit. We have applied certain recommendation of production within the dev setup, and then only we are able to achieve that. Although we can try it out, those who are watching this can try it out, let us know. But we have run this KeyCloak in the dev mode and enable the Cloud Run, enable the edge option for the KeyCloak. Edge option means that it runs behind the proxy. Okay, so by doing this setup, we are able to achieve the KeyCloak on the Cloud Run. And as of now, we found pennies of kind of a monthly cost for the entire setup. So majorly the cost is coming because we are using public for this Cloud Run to Cloud SQL. So this optimization, if we do it to the private, then also we can save some more cost over here as well. So so overall, this is the entire setup for our architecture in the GCP using the KeyCloak with the Cloud Run. And in the Java application, like normally how the request lands and the user clicks, opens up the web browser, they are presented with a login form. Okay, it fills up the detail in the login form. That request first lands on the resource server. Internally, this resource server is talking back to the KeyCloak, and then and get authorized, and their handshake happen, and then we are issuing this could be a couple of ways. Like either we can have the redirect happening on the browser itself directly via KeyCloak, or the backend service is talking to KeyCloak, doing communication, and then presenting a token back to the front-end application, and then particular token, the JWT token, will be presented in every other request to the backend resource server, and then the entire rest of the flow works. So so that's it, I would say, for this particular session about KeyCloak in the Cloud Run. Thank you.